Unit testing, the paradigm that has made many junior developers cry and many senior developers bang their heads when they see the red cross of death. So what is unit testing? Unit testing is literally a way to write tests for a certain unit and check if that unit works properly or not. This unit can be anything. In any language, it can be a function or a method. In essence, a unit should be logically isolated, meaning it should have the ability to detach itself from the system it is in and still continue to function properly. I appreciate this methodology highly, as it helps build muscle memory to write functions that are logically isolated and correct. You can run them without running the app. Yup, even front-end applications. Also, unit testing helps build the groundwork for any code base. If you're building a house, units are the foundation of it, and unit testing will give you the confidence that you laid the foundation correctly. Only then you should be able to build a house with a solid base. Still not convinced? Here's Uncle Bob defending unit testing in Quora. The link will be in the description. Now let's discuss some ground rules for unit testing. Before we do that, we just want to thank you for the overwhelming response that we got for the integration testing tutorial. If you haven't watched that, please check it out. The link is in the description. And for more tutorials like these, please make sure to subscribe. Now back to the ground rules for unit testing. The unit should be logically isolated. If two unit tests run simultaneously, the execution of one should not impact the execution of the other. Unit tests should not talk to an actual database, network, file system, system configuration, or any external dependency. The sole purpose should be to test the code inside the unit, not how it impacts other units. Unit tests should not have conditional or loop statements. This reduces the readability of the test. Tests should be fast. If they are not fast, well, you won't run them often. Tests should not include complex logic. They should prepare some data, aka arrange, execute a method, aka act, and expect some output in return, aka assert. And lastly, a single test should verify a single behavior. If we are writing a test to check addition, it should only cover one specific case of addition from X number of cases. For example, testing two values by providing one negative value, and then writing another test for testing two values by providing both negative values, and so on. This ensures that our tests are also well documented and become a reference point for new engineers who might have trouble understanding the feature. Implementing a unit test in Flutter is super easy. Let's say your client has just asked you to create a feature for your calculator app for dividing two integers and returning their quotient. You said, well, that's super easy, give me 4 minutes. You go ahead and create a class called division service and then a method called divide, which takes two integers, dividend and divisor, as input. You divide them using the divide operator and return the quotient. Pretty easy, right? So you push the code to the repository and you inform the client. Your client is also a programmer, but he doesn't like math too much. He used your division service but ran into an error. He's not sure what it is and is too lazy to look into it. So he replies, hey, the code you pushed is breaking. I'm not sure why. Can you take a look? You are shocked. You know yourself pretty well to write a function this simple without breaking it. What's wrong? You are unsure and you have no valid proof to back your work. So you open the code again and begin to debug it. You have no clue what's happening and how the client is using the function causing it to break. You have no way to test edge cases than to write unit tests for it. And that's the beauty of unit tests. You can test the logic of the functions without even running the app. So you open your Flutter project and begin to write tests for the division service class. Before we do that, go ahead and create a file called division_service.dart in the lib folder with the division service class and the divide method. The method is simple. It takes two parameters as inputs, dividend and divisor, which are of type int, exactly as your client asked. We divide them and return the quotient. We will be writing unit tests for this class. You'll see a folder called test in the root directory. Once you open it, you will see a file called widget_test.dart. It's useless for us, so we will delete this. This file is meant for widget tests and not unit tests. Create a file called division_service_test.dart. This file will contain unit tests for the division service class. Notice the suffix _test.dart. We need all test files to end with _test. This tells the Flutter framework that this file is a test file and will enable configurations associated with testing. After creating the file, import the Flutter test framework. If it gives you an undefined error, go to your pubspec.yaml file and add it to your dev dependencies. Now go back to your division_service_test.dart file and create a function called main. This will be the entry point for your test file. Add this this point, we are ready to write our first test. For unit tests, we will utilize a method called test, which has two important parameters. The first parameter is the description. This parameter helps you cover the documentation part. You can write descriptions that might help the future readers of the test. The other parameter is the body of the test. This parameter is used to execute the actual test. Be sure to always write your tests in the main method. Once we have added the test method to our main method, we will now prepare data, call a method, and expect some output in return. In our case, we will prepare values for dividend and divisor parameters, call the division service.divide method with our prepared values, and then expect the correct output in return. For assert, notice that we are using the expect method. This method has two required parameters, actual and matcher. We can pass our result from the divide method to the actual parameter and the output we expect in the matcher parameter. If the returned value from the divide method is different than what we expect in the matcher parameter, the expect method will throw an error and the test will fail. Otherwise, the test will pass. It's time to run the test. Notice the run or debug option above the test method and the main method. If you click on the one above the main method, it will run all the tests in the main body. If you click on the one above the test method, it will run that particular test only. Click on anyone and you should be able to see the test result in the debug console with a tick. This means that your divide method is working correctly. But if everything is working correctly, why is your client complaining? Let's go ahead and verify the behavior with some more test cases. In unit testing, the more test cases you write for one method, the better. But be mindful, the quantity should also reflect quality. We should not always write more test cases if there is no use for it. Let's add two more test cases. We have only changed the input values and the expected value. Everything else is the same. Run the main method and observe the output in the debug console. We passed our first two test cases, but the third test case failed. So this must be what the client was talking about. In the failed test case, we are dividing the dividend by 0, which means that the answer should be infinity. But how do we check that? We don't really have an infinity type in Dart. This is actually a math error, so we need to handle it programmatically in our divide method. Did you notice? Unit tests just helped us debug a problem that we really weren't thinking about. It's time to implement the solution in our divide method. Go to your divide method in the division service class and simply handle the case if the user inputs the divisor as 0. Now go back to your test file and run the tests again. All your test cases passed. You can now push the code again to the repository and inform your client with the confidence that your code runs on multiple scenarios. So to sum up, unit testing gives you confidence. It helps you write cleaner code. It helps you cover multiple scenarios, making sure your units don't break. Testing with multiple inputs can help you cover unseen edge cases that you might not have thought about otherwise. It helps you debug code easier. It helps you document your code, and much more once you get into it. Is it essential for an app to have unit tests? No, but to move faster in the long run, it is better to place unit tests for features so that developers can have the confidence to work on other features without breaking the existing ones. You just learned how to write unit tests, but this is not enough. Sometimes we have methods that are really hard to test. For example, it is possible that the method is a void method or has some external dependency like a network call. In the next video, we will discuss how to write tests for these methods. Till then, please make sure to subscribe to Runtime Snippets and don't forget to follow us on our socials.